Before delving into the details, it's fascinating to explore what atom smashers are. The Large Hadron Collider, LHC, operated by CERN, is the world's most famous and significant particle accelerator. This 17-mile ring of superconducting magnets is a marvel of human achievement. In fact, it is so powerful that it can replicate the conditions of the universe just moments after the Big Bang. But could this machine, designed to unlock the secrets of the universe, also hold the key to something more ominous? CERN, founded in 1954, is one of the world's most renowned research organizations, involving 23 member states and thousands of scientists. It is a hub for collaboration and innovation. The LHC is CERN's flagship project, but it's only one part of an enormous network of accelerators and experiments. Imagine a course not for vehicles, but for subatomic particles, testing the limits of energy, stability, and space itself. The LHC accelerates protons to near the speed of light, sending them on a collision course that simulates the energy levels present just after the Big Bang. These collisions generate temperatures far hotter than the center of the Sun. A complex array of magnets directs the protons while cooling systems maintain temperatures colder than space itself. The LHC's beams collide at 4 specific points around the ring, where 4 particle detectors, CMS, ALICE, ATLAS, and LHCb, are stationed. Each one serves a specific purpose, studying different aspects of particle physics. Together they act like gigantic cameras, capturing images of these high-energy collisions. Scientists then sift through the resulting debris, searching for clues to the elusive Higgs boson, the God particle, and other anomalies that might shed light on the fundamental building blocks of the universe. By studying the subatomic world, we gain valuable insights into the broader universe. But for every answer uncovered, new questions arise, and with each discovery comes a new challenge. The LHC is more than just a scientific instrument. It's a testament to human curiosity and progress, embodying our relentless quest for knowledge and our desire to understand the fundamental forces that shape our reality. However, as we push the boundaries of what we know, we must also consider the bigger existential questions that emerge. What are the risks of exploring the unknown? Could our pursuit of knowledge inadvertently unleash forces we cannot control? In the hallowed halls of CERN, where the limits of human understanding are constantly tested, a recent revelation has sent a shiver down the spine of even the most seasoned scientists. Brian Cox, a former CERN physicist and prominent voice in the field of particle physics, recently shared something that has captivated and unsettled the world. Cox revealed that the LHC's goal is to recreate a miniature version of the Big Bang, the very event that gave birth to our universe. This revelation raises the stakes, as the LHC's potential to uncover the mysteries of the Higgs boson and explore dark matter, the mysterious substance that makes up most of the universe, is both thrilling and dangerous. Imagine holding the power of creation in your hands, the ability to manipulate the very fabric of the universe. It's a tantalizing prospect, but one fraught with risks. The concept of a mini Big Bang is not just theoretical. It's a real possibility within the LHC. The extreme temperatures, pressures, and raw energy within the accelerator recreate conditions similar to the birth of the universe. It's as if you're standing at the dawn of history itself, witnessing the birth of existence. But with such immense power comes great responsibility, and the question remains, what if something goes wrong? A sobering incident from 1978 serves as a stark reminder of the dangers inherent in particle accelerators. Russian physicist Anat Borsky was working with a U-70 synchrotron at the Institute for High-Energy Physics in Russia when a malfunction caused a proton beam to pass through his skull. The beam, with energy that defies belief, traveled through his head, leaving a path of destruction. Remarkably, Borsky remained conscious and even walked to a medical center for treatment. While the damage was significant, causing hearing loss in one ear and partial facial paralysis, Borsky's mental faculties remained intact, and he continued his scientific career. This extraordinary incident highlights the immense power and potential hazards of particle accelerators. The risks associated with the LHC are not to be underestimated. The possibility of catastrophic reactions or even altering the very fabric of reality is not merely science fiction but a serious concern voiced by respected scientists. One of the most unsettling possibilities raised by the LHC is the potential to create a miniature black hole. Black holes are regions of space where gravity is so strong that not even light can escape. These cosmic vacuum cleaners devour stars and consume everything in their path. The idea that the LHC could create such a phenomenon, even on a small scale, is both mind-boggling and terrifying. Could this tiny black hole grow uncontrollably and eventually consume the Earth from the inside? While scientists at CERN have reassured the public that any black hole created would be unstable and evaporate quickly, the mere possibility has sparked fears and awe. The prospect of such immense power at our fingertips raises questions about the ethical implications of such experiments. It's crucial to understand how the LHC could create a black hole. It's all about the fundamental mechanics of particle collisions, where energy densities are concentrated to a degree that could, in theory, produce such a phenomenon. In summary, while the LHC represents one of humanity's greatest scientific achievements, it also brings with it profound risks and uncertainties. The Large Hadron Collider, the pursuit of knowledge, is a powerful operates force,
like a gas
but as
pedal
we peer
that
into the
accelerates
unknown,
protons
we must
to nearly
tread
the
carefully,
speed of light.
aware
The
of the
energy
potential
generated by
consequences
these
of pushing
collisions
the
is
boundaries
immense,
of discovery,
capable of distorting the very fabric of spacetime.
Imagine stretching a trampoline tight and then dropping a heavy object onto it. The fabric curves, and if the object is massive enough, it creates a well so deep that nearby objects could fall in. This analogy helps explain what might occur at the LHC in the realm of quantum physics, where the laws of the universe can be both strange and extraordinary. One hypothesis suggests that hidden extra dimensions might exist within our universe. If they do, the LHC's experiments could potentially interact with them, creating a gravitational well that could form a small black hole. This strange behavior of particles has captured the attention of renowned scientists, including the late Stephen Hawking. In his book, he warned of the possibility that the Higgs boson might become unstable at extremely high energy levels, leading to a catastrophic event called a vacuum decay. Such an event wouldn't just destroy Earth. It could potentially annihilate the entire universe. Sir Martin Rees, a respected English cosmologist and astrophysicist, also voiced concerns about the experiments conducted at CERN. In his book on humanity's future, he explored the potential risks of particle collider tests, including those at CERN. Though he assigned a low probability to these disastrous outcomes, he emphasized that even a small chance should be seriously considered due to the high stakes and the razor-thin margin for error. The scientists at CERN have conducted simulations, examined theories, and implemented strict safety protocols to ensure the LHC's experiments are secure. Physicist Brian Cox himself reassured the public, acknowledging the concerns but affirming that the energy levels involved are well within the natural range the Earth already experiences. The likelihood of creating a stable black hole is extraordinarily low, and if one did form, it would be so tiny and unstable that it would dissipate quickly, producing a burst of energy, an event predicted by Hawking called Hawking radiation. Some have speculated that the LHC's tests might even open a portal to another universe or dimension. While this idea is largely dismissed by mainstream scientists, it has captivated the imagination of many, leading to fears and myths about the consequences of such experiments. But where did this idea originate, and what does it mean in terms of scientific inquiry? The concept of extra dimensions isn't new in physics. String theory, a leading candidate for a unified theory of everything, proposes that there may be more than the standard 3 dimensions of space and one of time. These extra dimensions could be hidden from our perception, yet potentially accessible under extreme conditions. The LHC could, in theory, act as a key to unlocking these hidden dimensions, creating ripples or waves that might reveal them. However, it's important to remember that while the LHC is a powerful tool, there's no definitive evidence to suggest it will open a gateway to another universe, or to a hellish one for that matter. Nevertheless, the allure of the unknown and the enigmatic nature of quantum physics continue to fuel speculation, captivating the public's imagination. Should we be worried about the LHC and its potential dangers? It's easy to get swept up in sensational headlines and fears of global catastrophe, but the reality is that the scientists at CERN are highly cautious. They have put in place rigorous safety measures, conducting thorough reviews and assessments to ensure the safety of the LHC's operations. The potential benefits of this research, advancing our understanding of the universe, discovering new particles, and exploring dark matter, are truly remarkable. It's not just a display of human ingenuity, but a window into the fundamental workings of the cosmos. Like any major scientific breakthrough, the LHC comes with its share of risks. We must approach it with a balanced sense of awe, respect, and awareness. The LHC represents the frontier of scientific exploration, where theoretical physics meets experimental reality. Its potential to answer fundamental questions about the universe, such as the origins of mass and the nature of dark matter, is unparalleled. Despite the extensive safety protocols and simulations, the LHC still evokes a sense of mystery and fear for some. The sheer scale of the machine and the energy it generates are awe-inspiring, and each new experiment opens the door to unfamiliar realms of science. While most scientists remain confident about the safety of LHC experiments, there remain uncertainties. What if new, unexpected phenomena emerge that challenge our understanding of physics and the laws that govern the universe? The LHC pushes the boundaries of human knowledge and tests the limits of our control over the natural world. As its particle collisions mimic conditions from the early universe, these experiments raise existential questions about the potential consequences of altering the very fabric of spacetime. Nevertheless, the discoveries made at the LHC have been groundbreaking. It has led to the identification of the Higgs boson, advanced our understanding of the Standard Model, and opened pathways for potential breakthroughs that could shape our technological future. In the end, the pursuit of knowledge remains one of humanity's most ambitious endeavors. Scientific discovery is rarely without risk, and the LHC is no exception. It delves into the fundamental forces of nature, gravity, electromagnetism, and the nuclear forces that have shaped the evolution of matter.